Hello everybody, good morning, welcome once again. So we are in our fifth module, last module, and this is our 8th class for the fifth module. See, in this class, nothing new we are going to study, only a simple concept called Instantaneous Center of Rotation. What is Instantaneous Center of Rotation? That's all. And we will have a small revision on what we have studied earlier in this module. That's all. So today's portion is Instantaneous Center of Rotation. Instantaneous Center of Rotation. Okay. So before seeing what is Instantaneous Center of Rotation, we can have a small recall of what we have studied earlier, a small revision. So we'll have our syllabus with us. So look into your syllabus. First is rotation. So for this rotation, we have already seen what is rotational motion, how we relate a rotational motion, what is the difference of rotation from linear motion, what is the difference between the linear and rotational motion. Then kinematics of rotation. So in kinematics of rotation, we saw the relationship between the characteristics of rotational motion. That is relationship between the characteristics. What characteristics? The angular displacement, angular velocity and angular acceleration with respect to time. So we used the rotational equation of motion to solve the problems for this part, that is for kinematics of rotation. So kinematics of rotation, when it comes to kinematics of rotation, we use equation of motion for a rigid body rotating about a fixed axis. So if the rigid body is rotating about a fixed axis, then that is kinematics of rotation. Right? So kinematics, you know, the relationship between the characteristics, the geometrical characteristics, angular displacement, angular velocity and angular acceleration with respect to time will be considered, and without considering the forces responsible for causing these motions. So when a rigid body is assumed to rotate about a fixed axis, that is called kinematics. So kinematics of rotation. Then, so we saw the concept, we saw the problems. After that, we saw what is rotation under a constant moment. So here the moment or torque, moment also called torque. So when you are considering the rigid body rotating under a constant moment, we call it as kinetics, because force is also considered. So force responsible for causing the motion is also considered. That is why it is kinetics. So for solving the kinetics of rotation, we used, that is force is equal to mass into acceleration, we use moment is equal to, or moment or torque is equal to moment of inertia multiplied by angular acceleration. Then we saw what is the relationship between linear displacement and angular displacement, linear velocity and angular velocity, linear acceleration and angular acceleration. So linear displacement is equal to the radius into angular displacement. Linear velocity is equal to radius into angular velocity. Linear acceleration is equal to radius into angular acceleration. Then Force is equal to mass into acceleration. So moment or torque is equal to moment of inertia into angular acceleration. Then we had two principles. So those principles are moment energy principle, moment energy principle, and moment impulse principle. So moment, summation of the moment is equal to rate of change of kinetic energy, and moment is equal to impulse, change of impulse. So using these two concepts, we saw the problems of rotation under a constant moment. So up to this is our 50%, almost more than half of our portion of our fifth module comes here. The second part, so this is our part 1. So this, up to this is the part 1, the first half of module 5. Now we are in our second half of module 5. See, second half of module 5, we have only the concepts, no problems are given. If you look into your syllabus detail, you can see these portions, that is the course objective of these portions are CO1 and CO2. So CO1 and CO2 are understanding the concepts and recalling the concepts. So you will have only theory part. Course objective 3, 4 and 5 comes under applications. So for this part, that is for the second part of this module 5, you have only the concept. So only some theory parts, and if required, some simple problems to understand, that's all. So in the previous class, last class, we saw what is the plane motion of rigid body. So what is the plane motion of a rigid body? It is a combination of both linear and rotational motion, and we saw examples also. So how the rigid body motion can be a combination of both linear and rotational motion. That is what we saw in the last class. Today, here also only the concept. So today we will see what is instantaneous center of rotation, because we have only limited small portions. Within another 2 or 3 class, we will be completing the syllabus. So by next week, we will be completing the syllabus. Okay. So today we will just see what is instantaneous center of rotation. So instantaneous center of rotation in rotation of rigid bodies, that is when the objects are subjected to rigid motion. You saw example in the last class. It is possible to locate a point in the plane which has zero velocity. See, in the rigid body is rotating in a plane. So in that plane, you can locate some point which has zero velocity, and at any instant, the plane motion of other points. That is, you will have one point which has zero velocity, and all the other points will have the rotation with respect to this point which has zero velocity. Right? See, for example, you can have a ball and you rotate it. See, there will be a center point which will have zero velocity, and all the remaining points in that ball will move with some other velocities, with respect to this particular point. So the point which has zero velocity is called instantaneous velocity. So we will read once again. In rotation of rigid bodies, it is possible to locate a point in the plane. So this point can be located either on the rigid body or on the plane, somewhere in the plane, which has zero velocity at any instant, and hence the plane motion of other points may look as pure rotation about this point. See, only if you have one point, only if one point, see, you are moving a rigid body. When we move a rigid body, only if a point is kept fixed, your motion can be rotational motion. Otherwise, it becomes linear motion. So this instantaneous center comes for rotation, rotational motion. Only for rotational motion, you will have a point where the velocity is zero, and the rotation is made with respect to that point, that fixed point. Okay, that's all. We will see what are the characteristics of instantaneous center of rotation. Okay, before that, sorry. So such a point is called instantaneous center. So the point which has the zero velocity is called instantaneous center, and the axis passing through this point and at right angles to the plane of motion is called instantaneous axis of rotation. So I don't have any objects now. Okay. Listen, for example, you can take this cylindrical, see, this is cylindrical body. You can rotate this, right? When you rotate this, see at the center, there will be a point and an axis passing through that point which has zero velocity. So that point is called instantaneous center, and the axis passing through point at right angles to the plane of motion. See, if the plane of motion is like this, this is moving like this, right? So at right angles to this plane, this axis is called the instantaneous axis of rotation. If this object is rotating like this, if the object is rotating, see, if the object is rotating like this, at the center there will be a point which has a zero velocity, and this axis passing perpendicular to the axis of rotation. So if this is rotation, the axis perpendicular to the rotation is like this. So that is called the instantaneous axis of rotation. If this object is rotating in this manner, then this vertical axis, the center vertical axis will be called as the instantaneous axis of rotation. So hope you understood. What are the characteristics of instantaneous center? So it may be located inside or outside the body. Okay, sometimes you can locate the point somewhere inside or outside the body. So the location of instantaneous center changes at every instant, and the path traced by it is called a centroid. If the instantaneous center is changing at every instant, then that path, that is the path traced by the instantaneous center. See, one time you will have instantaneous center at this point, then the instantaneous center will be moved to some other point. If the case is that, then the path traced by this instantaneous center is called as centroid. Now, third characteristic is the instantaneous center has zero velocity. So only 3 characteristics, and that's all for today. Hope you all understood. See, because we are going to complete the portion, I am going little slow. We have only a few concepts to complete. So this part is over. That is, in our syllabus, the kinematics of rotation is completed, kinetics of rotation is completed, general plane motion has been completed, and instantaneous center of rotation is completed. So I did not continue the next part today. The reason is, next portion is a different portion. See, in the fourth module we saw rectilinear, curvilinear motion. Fifth module is about rotational motion and vibrational motion. So the next part is about vibration. So that is completely different from what you have studied now. So vibration. So that is why I have stopped with this today. The concept of vibration, random vibration, and we will see it in the next class. Next portion we will continue in the next class. So thank you for today. Thank you for listening. Thank you very much.